I'm not giving up, giving up now. I'm not giving up, giving up now. I'm not giving up, giving up, giving up on you.
Hello, welcome to another episode of Green's Chemistry Shorts. Today, we will be discussing how to count the number of sigma bonds in a molecule and how to count the number of pi bonds. Additionally, we'll discuss how to account for hybridization and bonding schemes. So, first we have the molecule for indigo. Okay, as you can see, this looks pretty scary. A lot of things you probably haven't seen in lecture, but if you take the things that I taught you in lecture, counting the number of sigma bonds and pi bonds should be a piece of cake. All right, so anytime you see any bond between two atoms, whether it's a single bond, double bond, or triple bond, you must always remember that a sigma bond is always present, okay? So just in case you forget, we have a carbon-carbon single bond. There's a sigma bond present, okay? For a double bond, whenever we have a double bond, one of these bonds is considered to be a sigma bond, while the other is considered to be a pi bond. And then, of course, in the case of a triple bond, one of these is considered to be a sigma bond, while the other two are considered to be pi bonds. So now that we have that reminder, let's go through the indigo molecule and count the number of sigma bonds and pi bonds. So we'll start with within the rings, counting the sigma bonds. Okay? So remember, we're only counting the spaces between atoms. Okay? So we're going within the rings. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay? So that's 21 within the rings. We need to go outside of the molecule on the periphery to count the rest of the sigma bonds. So after 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, and 33. So we have a grand total of 33 sigma bonds. Now on to the pi bonds. Okay, remember, whenever we have a double bond, that one of these bonds is considered to be sigma, which we've already counted. The other one is considered to be pi. So let's sweep from left to right, counting the number of pi bonds. Okay, so here we have 1 pi bond, 2, 3. If we look out on the periphery where this carbon double bond is, this is 4, 5 here, 6, 7, 8, and 9. So we have a grand total of 9 pi bonds. Okay? Simple enough. Okay, now we'll focus on the areas where I have, I guess, rectangles in green, where we're looking at the number of charge clouds and also hybridization. Okay? If you remember from lecture, the hybridization scheme has a lot to do with the local structure of the central atom. And if you also remember, any one of these atoms within this structure, within the ring, and even this oxygen, can be considered to be a central atom. Okay? So if we focus on the areas in green, all right, we'll start with number 1. If you notice, this carbon has 1, 2, and 3 charge clouds around the central atom, which is, of course, carbon. Okay? Anytime we have a 3 charge cloud scheme, the structure ends up being trigonal planar. And the type of hybridization associated with the trigonal planar structure is considered to be sp2. Okay? So the number of charged clouds again, 1, 2, 3. We have 3 charged clouds. The hybridization is sp2. Okay? Also remember, when we talk about charged clouds, we're also referring to what? Areas of electron density. So single bonds, double bonds, and triple bonds are all considered to be a part of one charged cloud. Okay? Number 2, this oxygen. Okay, you're probably thinking to yourself, oh, okay, well, why would he consider this to be a central atom? Well, as you can see where the lone pairs are, they're still considered to be areas of electron density or charge clouds. Okay? Much like number 1, number 2 also has 3 charge clouds. Okay? One set of lone pairs, the other set of lone pairs, and also this double bond between the carbon and the oxygen. Okay? So we still have 3 charge clouds. Okay? According to your text, 3 charge cloud schemes, a trigonal planar geometry is associated with it. And of course, if you have a trigonal planar geometry, you still have sp2 hybridization. Okay. Last and certainly not least, we have number 3, in which we have nitrogen bonded with 2 carbons and 1 hydrogen. But hold on, we also have a lone pair of electrons right next to the chemical symbol for nitrogen, meaning that we have an additional charge cloud. So if we count all the bonds and also the lone pairs of electrons, so that's 1, 2, 3, 4, that means that we have 4 charge clouds. Okay? You have 4 charge clouds here. Okay? Anytime that we have a 4 charge cloud case, that means the electronic geometry or the structure ends up being tetrahedral. Okay? And the hybridization associated with the tetrahedral structure is sp3 hybridization. sp3 hybridization. Hopefully this helped you out. Tune in for the next episode of Green's Chemistry Shorts. You've just been shorted.